किसका है ये तुमको इंतजार में हूँ ना. Yes, you heard it right. I'm back with another video, the most awaited video on the topics for the syllabus for MCQs. So here we begin it. The first topic is loop detection in English. So you have to know the problem statement. It might be asked to take. So the problem statement is like you have been given a linked list with a loop and you have to say true or false or say yes or no that there exists a cycle or not. The probable code uses the Floyd's algorithm, fast and slow pointers, and slow moves one step at a time and fast moves two steps at a time. When they reach at the same point, that is the indication that cycle exists. The program would run for big of n, most efficient program, time of space complexity of big of 1. This could be also asked to tip, so just give it a glance. Memory management, network and graph theory, compiler design games and simulation, linked list problems. Okay, and you could also be given an input, say 1, 2, 3, 4, and 2. That means it's pointing back to 2. So you might be asked what is the output. So in this case, you have to say yes, cycle exists. Okay, so this could be the scenario for this program. Next, we have segregate even and odd nodes in a linked list. So the task is to rearrange the nodes of the linked list in an order such that all the even nodes, the nodes which have the value even and the nodes which have the value odd. So all the even nodes should come in the first, like the leftmost side, and all the odd nodes should come in the rightmost side. And the even and odd data should be consecutive and should follow the order. So we'll be using an even list, an odd list, store the values, and time complexity, big of n, big of 1. We'll be using some pointers that is the even head, even end, odd end, something like that. And the applications could be pre-processing for algorithms, load balancing, partitioning for simplicity, sorting or filtering data stream, linked list problem. Again, in this case, if the input is given something of this sort, 1, 6, 3, 2, 0, 4, and let's say 5. So what will be the output? All the even nodes should come in the first side. So the first even node is 6, then we have 2 in order, then we have 0 in order, then we have 4 in order. And then the first odd node is 1, then we have 3 in order, and then we have 5 in order. So this would be the answer. Okay, moving ahead, we have sort bitonic in DLL. DLL means doubly linked list that has previous and next both pointers. Okay, now what is the meaning of bitonic? This could be asked in MCQ, and that is a sequence first monotonically increasing and then monotonically decreasing. Okay, so it may be like an example be first it's increasing. So 1, 2, 3, 4, 5, and then 9, 8, 7, 6. So this is a bitonic data. Okay, and it has two parts, increasing part followed by decreasing parts. Okay, identify these parts helps with the problem to manage the sub problems. And this is the steps we will be using in the actual problem program. So we would split the list in two parts, decreasing and increasing. Then we would reverse the decreasing part to make it also ascending. And then we will compare each and every data of increasing part and decreasing half. And then we would merge them in a sorted linked list. Okay. The time complexity would go for big of n and the space complexity would go for big of 1. Okay. Again, coming to the applications part. So sorting specialized data, parallel computing, data analysis and compression, networking, and optimization problem. Okay, coming to the input and output examples. So input would be like 1, 2, 3, 4, 5, and then 9, 8, 7, 6. What will be the output? Output would be 1, 2, 3, 4, 5, and then 6, 7, 8, 9. Okay, I hope it's clear. It's simple. ठीक है, आगे चलते हैं. Let's move forward. we have merge sort in doubly linked list. So लिंक लिस्ट would be given, doubly linked list would be given, and हमें उसको sort करना है using merge sort. Merge sort, as you know from basic arrays point of view, तो क्या करना होता है, we have to continuously break the array or the data into two halves based on a mid element, mid index, and we divide the array elements or elements basically up to दैट पॉइंट व्हेन, जब उस पॉइंट तक जब तक हर एक एलिमेंट एक एक साइज का बच जाए, एंड देन वी गो अपवर्ड्स इन द ट्री, ऊपर जाते जाते उनको मर्ज करते हैं बेस्ड ऑन इंक्रीजिंग, दैट इज ग्रेटर देन और लेस देन फॉर डिसेंडिंग ऑर्डर ascending order. Okay, similarly we will do over here also, and then that would give a time constant of n log n in case of any approach for linked list, doubly linked list, arrays, anything, and space complexity of log n for recursion stack. Okay, so we'll use the recursion over here, and then applications could be like these: sorting large linked data structures, database management system, optimal sorting for sparse memory, backend operations, and foundation algorithms. You can give a read. Okay, and a probable input would be some unsorted data. Okay, and output would be sorted in ascending or descending order. Okay, using merge sort algorithm, divide and conquer approach. Now coming to the next, we have minimum stack. So as the name suggests, we would be using stack, and the name also suggests minimum. That means at any point of time after pushing some values in the stack, you would be asked what is the minimum element. Now, the most easiest approach that you would think is that I'll keep on searching in the stack, and when I get a minimum element, I'll report it. Okay. The next time if I've asked second minimum element, then I'll keep on searching in the stack again and considering not the already found minimum element to find the next minimum element. But this is not a good approach. It will take a lot of time. और टाइम लगेगा, ठीक है. Big of n हर बार चलेगा. तो हमें क्या करना है? What we want, our target is to do it in big of 1. Okay, so we have to find the minimum element from the stack in big of 1 operation. In case of push also it's take big of 1. In case of pop also it's take big of 1. In case of peek also it's take big of 1. And we also want to get min in big of 1. So we have to complete a function called getMin to get minimum value from the stack elements in big of 1 time constant, that is instantly. Okay, तो हमारा ये क्वेश्चन है. Then let's read the problem statement once. So the goal of minimum stack problem is to design a stack in addition to standard operations push pop peek to retrieve minimum element in big of 1, and the approach to get it efficient in big of 1 is that we may use an auxiliary stack, a helper stack, okay, to keep a track of minimum values. And at an instance, when we want to get a minimum value, we will be taking the value from auxiliary stack, that is the helper value. Okay, so it will go for big of 1 time and big of n for space because of auxiliary stack, helper stack. Okay, now the applications are efficient data retrieval, histogram problems, dynamic minimum tracking, algorithm optimization, game development. Okay, now suppose input is of this form. It says push 10, then it says push 15, then it says push 12. Okay, so after these operations, the stack will have elements in the form 12, then below it will be 15, and below it will be 10. Okay, now I want the minimum element. So then I call a method called getMin in the first time. So it must report 10. Okay, when I call getMin for the second time, okay, then it must report the second minimum element, that is 12, not 15. Okay, and if I call the third time, then it must say that the third minimum element is, yes, 15. So this is the plan to solve. You have to complete this getMin function in a way using the obvious step. ठीक है. So this could be an input and the output could be asked in any of the formats. Coming to next problem, that is celebrity problem. Very interesting problem. तो बहुत मजेदार problem है, इसमें देखते क्या होता है. So a person can be called celebrity if दो शर्त है हमारे पास. The first one is says that celebrity does not know anyone. Okay, उसको वो किसी को नहीं जानता and everyone knows him. सब उसको जानते हैं. For example, Shahrukh Khan is there. We all know Shahrukh Khan. You might also know Shahrukh Khan. Okay, but does he know you personally? No, he may not know you unless and unless he is very close to you. Maybe. Okay, तो अब इसको सॉल्व करना है. What will be the scenario? Coming to the input output first, then we'll look ahead. So input ऐसा होगा कि हमें एक मैट्रिक्स गिवन होगी. ओके, डबल ई मैट्रिक्स, 2D मैट्रिक्स. ओके, supposingly it's like 0 1 1 0, then it is 0 0 0 0, then it is 0 1 0 0, for example, and 1 1 0 0. Okay, so this is a 4 cross 4 matrix. 4 cross 4 matrix. So n equal to 4. Now we have to say who is the celebrity. Celebrity. Celebrity is 1 or 2 or 3 or 4%. तो हमें बताना celebrity कौन. So the key points that we found were supposingly that celebrity knows no one and everyone knows him. Next point is that if I say matrix of ith row, jth column, and if this value is equal to 1, what do you mean by this? We mean that I knows j. Okay. Similarly, if I say matrix of j I is equal to 1, so it means j knows I. So if in this scenario I knows j and celebrity is someone who knows nobody, so if I know someone, can I be a celebrity? No, maybe j is a celebrity. And in this scenario, j knows I, that means j knows someone, so maybe I is a celebrity. Okay, so if we see as the input ones, so 0 1, so let's write the index also then. 0th row, first row, second row, and the third row. Okay, similarly the index for columns also. So if you first focus on the first row elements, okay, they are all 0. That means one knows nobody. Okay, and if we see the column for first 0 and then 1, if you see the column for 1, so 0 knows 1. Okay, I mean 1 knows 0 and 1 over here also and 1 also. That means if we focus on the index 1, row and column, then the row signifies that ith person knows nobody, and if the elements accept the intersection, I should not be equal to the candidate. So if we say our probable candidate, maybe अगर हम सोचते हैं कि 1 हमारा celebrity हो सकता है, तो उस सिनेरियो में क्या होगा कि 1 किसी को नहीं जानता है, that we come to know from the row, and others know him, that we come to know from the column, and this intersection element should be 0. Okay, so we conclude for this example input, our output is celebrity is 2. Second person is the celebrity. Now, there is another point to consider that minimum how many celebrities would be there? There can be zero celebrities. And at max, how many celebrities can be there? There can be only one. Because if we suppose that there are two celebrities, then it's not possible because one of the other person has to know no one and one of the other person has to know everyone. So if someone knows everyone, then can't be the one whom we say that he knows no one. Okay, it's not complicated. It's very simple. Okay, तो इस तरह का input अगर देगा, तो we have to say this is the output. Okay, I hope the input output scenario is simple, clear. Okay, coming back to the leftovers. So time complexity big of n and space complexity also big of n. Okay, you might think time space complexity should have been big of n square. No, it won't be because that was matrix as input. Okay, and we are using stack for some consideration. So it will be big of n, helper variable, helper auxiliary space, and time was to be big of n because we are not going into the ij loops to iterate in the array. I mean 2D array. So वो brute force तरीका है उसमें हम नहीं जा रहे. Most efficient is this one, which will take big of n and big of n for both time and space complexity. Okay. Coming on to the applications, social networking analysis, game theory, database system, event planning, and graph theory problem. Okay, moving ahead. I hope this problem is very clear to you. It's very interesting. You might read it once. The next problem in our bucket is Tower of Hanoi. So this is a very old and very famous problem based on a story. We'll not get deep into the story or at all. ठीक है, तो प्रॉब्लम स्टेटमेंट क्या होगा? हमें एंड डिस्क गिवन होगी. ठीक है, एंड डिस्क गिवन होगी एंड इस तरह गिवन होगी इन दिस फॉर्मेट दैट द बिगर डिस्क will always lie below the smaller disk. Okay, so the disk will be set up in ascending order, the smallest at the top and the largest at the bottom. Okay, so if there are two disks, so the one disk big will be below and on the top of it, there will be a small disk. Okay, so what is the task? Task is move the disk from source to destination, but at any point of time, किसी भी टाइम पर ऐसा नहीं हो सकता कि स्मॉल डिस्क के ऊपर बड़ी डिस्क रख सकते हैं. ओके, वी कैन नॉट पुट small disk over a big disk. Okay, larger disk. So what we want now, we need a helper rod, helper variable. So what we'll do, we'll take three disks, I mean three rods. One is the source, then the helper, then the destination. And with the help of helper, we'll try to go to the destination. Okay, you might read these things also. The same is given. Over here, helper is considered as auxiliary rod and destination is said to be the target rod. Okay. So the best case is n equal to 1, only one disk, and we don't have to move it at all. It will directly go to destination without the help of helper. Helper की help के बिना से हम जा सकते हैं destination because it's only one. Now suppose there are more than n disks. So the time complexity for our recursive algorithm would go to 2 power n, and the space complexity will be big of n because of recursive calls for the stack. Okay, and one more point to consider, if it says like n equal to say 2, then how many movements will be there? We have to calculate number of movements, okay, to get the final answer. So the formula is 2 power n minus of 1. So in our scenario, n is 2, so it will be 2 power 2, 4 minus 1 equal to 3 will be the answer. In case n is equal to 3, so the required answer will be 2 power 3 is 8 minus 1, 7 movements. Okay, this could be a problem MCQ in this regard. Now coming to the applications, application क्या है हमारे यहाँ पे? Algorithmic thinking, data structure manipulation, real-time scheduling, disk balancing and distributed system, educational tools. Okay, you can keep it read. Coming to the next. Okay, so इसका नाम है stock span problem and its application lies in stock market analysis. Okay, so इसमें क्या होगा? What will happen in this? You will be given an array of some data. Okay, and you have to find another array, the output span array, that will have the count of how many days consecutively before the current day and those data were less than or equal to the current day. Okay, example input से समझते हैं. Input will be of the scenario, say you have 7, 2, 1, 3, 3 and 1 and 8. Okay, तो आउटपुट क्या होगा? ठीक है, सबसे पहले 7th एलिमेंट पे बैठते हैं. वी फर्स्ट पॉइंट टू 7th एलिमेंट एंड वील से is there anyone greater than 7 on the left hand side? It says no, nobody. So he himself is uh, small to itself and for only 1. So 1 will be the answer. Then for 2, it will be itself because 7 is big, not small. Then for 1, again it will be 1. Nobody on its left is considerably smaller than it. Then for 3, the answer will be 3 itself because 3 is left is 1 small, then 2 small, 7 is big, so we'll stop and we'll consider 3, 1 and 2 all. So it will be 1, 1, 3 so far. Coming to 3 again. So 3 is less than equal to 3. Yes, less than 1 is less than 3, 2 is less than 3. So we have a span of 4 over there. Okay. Coming to 1 similarly, it will be 1 itself because on its left consecutively we find first 3 and it's big. So we will not find any other element and statically say he itself is smaller than equal to itself. So हमें output यहाँ पे 1 मिलेगा. Coming to 8. 1 is smaller than 8? Yes. 3? Yes. Yes. Okay. 7 also. So how many elements are there? 1, 2, 3, 4, 5, 6 and he himself 7. So the output over here will be 7. So this is the output you have to say and we call it as the span array or array span. Okay. So you will have to do the input output in this format. Here we'll be using a concept of next greater element on the left hand side and you can also check problems related to next greater in the right hand side, then next smaller in the left hand side and next smaller in the right hand side. Very popular applications or implementation problems based on stack and this could be asked in any of the problems. So any sub problem say stock span problem in this scenario, we are using NGL concept over here to find the outputs. Okay. Coming to time complexity, big of n, space complexity, big of n. Okay. And the application, the most popular application stock market analysis, as the name suggests, also suggests stock span problem. ठीक है. Financial data analysis, histogram problems, weather trends, competitive programming. You can give a read. Coming to the next problem is priority queue using W linked list. So the first question is what is priority queue? Priority queue क्या होता है? तो ऐसा क्या होता है? हमारी queue के बारे में आपको पता हो. तो what is a queue? A data structure that works on the principle of first in, first out. Okay, and stack works on the principle of last in, first out. This is also a probable question. Now, what we have to do? There will be a doubly linked list, and using that we have to implement priority. Okay, तो आप इसको read कर सकते हैं. Not a tough thing at all. Okay. Now, what will happen eventually? We can insert a big of n time of the thing due to traverses to find the position. Then big of 1 delete and big of 1 peak. Applications, scheduling tasks, 6 stars algorithm, data stream processing, event handling, job scheduling, real-time system. Okay, coming to the important points. So priority queue by default, if you will think on collections framework, Java collection framework, okay, तो priority queue by default कैसे वर्क करता है? Ascending priority पर, ठीक है. एंड हमें अगर डिसेंडिंग कराना होता है तो उसके लिए एक एक्स्ट्रा लाइन ऐड करनी होती है. ठीक है. नेक्स्ट, प्रायोरिटी क्यू कलेक्शन फ्रेमवर्क से कैसे लिखते हैं? हाउ वी राइट इट डायरेक्टली? सो वी कैन राइट लाइक प्रायोरिटी क्यू इंटीजर pq is equal to mean priority queue. That's it. Okay. Okay, good. But if I say you have to implement a queue, not priority queue, okay. So how we'll write? And make sure you have done a line the very top of the program before the class, that is import java.util.start or import java.util.priority queue if you want only priority queue to have facility. ओके, तो क्यू के लिए क्या करेंगे, जैसे सिंटैक्स हमारा ऊपर था प्रायोरिटी क्यू पी क्यू इज इक्वल टू न्यू प्रायोरिटी क्यू, यहाँ पे ऐसा नहीं रहेगा. फिर से क्यू इंटीजर से क्यू इज इक्वल टू न्यू क्यू. No, it will not do. So what you have to say, you can implement it using linked list. So make it a point at the right hand side, you have to write linked list, not queue. Okay. ठीक. Now what is, okay, as I mentioned, ascending order priority will be considered. So if elements 5, 4, 3, 2, 1 are pushed into the priority queue, and if you say pq.p after this word, so you will find 1 is the element. Okay. Supposingly you push first element as some 999, some 57, or some random element. And at a point of time, if you say pq.p, okay, so what you will get the first minimum element. And if you say pq.pole, then you will get the first minimum element also, and that will be removed from the array. I mean the priority queue. तो आपको मिलेगा भी एंड वो रिमूव हो जाएगा. तो नेक्स्ट टाइम जब आप फिर से लाओगे pq.pole, तो क्या होगा, आपको सेकंड मिनिमम एलिमेंट मिल जाएगा एंड वो प्रायोरिटी क्यू में से रिमूव कर दीजिए. ठीक है. तो इसको असेंडिंग ऑर्डर के लिए भी डिसेंडिंग ऑर्डर के लिए भी यूज करते हैं लोग. And then also to get the minimum elements also, maximum elements also, it's a very good approach with n log n time of the CPU to sort itself. Okay. Coming to the next, which we have is sort without extra space. इसमें क्या हो रहा होगा, we'll put the data taken as input in a queue and then we have to sort the queue without using extra space. तो हम क्या करेंगे, we'll find the minimum element in each iteration and put it at the back hand side, that is the rear side of the queue. Okay, so guess what, we'll be using bubble sort over there and then time also will be in square. Are we using an extra space? No, we are not using, as the name suggests. तो इसका क्या होगा, big of one space functions. ठीक है. And yes, so the applications could be memory constrained systems, queue based data processing, streaming data, embedded system, event management. Okay. The next problem is stack permutation. And okay, so this is the last program in our bucket. Good to go. तो इसमें क्या होगा, हमें दो arrays given होंगे, say an input array and then an output array. You have to check if the output array can be achieved with the help of input array and stack operations, that is push and pop. ठीक है. अगर नहीं होता है तो we say it's not a stack permutation. Okay, you can give it a read. And then time of sleep will be big of n using the stack and big of n again the space complexity. So applications, expression evaluation, compiler design, real-time scheduling, reversible operations, data structures, simulation. Okay. Coming to the input. So if you are given at input array, the format say 1, 2, 3, and an output form array, the format says 2, 1, 3. Okay. So what will happen? You will create a stack and you will push an element, that is 1, from the input array. Then you will check if it's equal to the output array element. You will check with 2. You will say no, it's not equal. Then you will push another element, that is 2. You will again check, says yes, 2 is equal. तो जब तक इक्वल है तब तक पॉप करते जाओ. तो okay, then this is also equal. Oh, stack is empty. Stop. Then again push the remaining element from input. We say this. Again we will check. It says yes, 3 is equal. Remove. Okay. Now we have traversed the input array completely. Now the stack is empty. We will say if empty, then yes, we can do it. That is, हमें स्टैक कॉम्पिटिशन के थ्रू से प्रूव कर दिया कि आप आउटपुट एरे को अचीव कर सकते हैं. ठीक है. So that is how you have to do. And the output could be like say yes, no, okay, or say 1 or say 0, or it could be true or okay. In our scenario for this context, it will be yes or 1 or okay. So that's the questions. And yes, so here we have a dedicated time and space complexity table made for you. So you can give a glance at it. Meanwhile, I'll grab some water. ठीक है, तो ये तो बातें हो गई हमारी the 11 programs that could be asked. Coming on the questions in general based on linked list. Okay, linked list, doubly linked list, stack, queue, priority queue, deck. Okay, so you could be asked to implement add first for linked list, doubly linked list. Okay, you could be asked some general questions on this. So you can be asked, say, what are the features of a node? So the output will be next pointer and data variable or value variable. Okay, then to travel in the linked list, doubly linked list, what are the pointers used? So the answer is head and tail. Okay, next, difference between linked list and doubly linked list. That is, in linked list we have in singly linked list, that is we have only next pointer. But in doubly linked list we have next as well as previous pointer. Okay, now coming on to stack. So we have push operations, pop operations, peek operations. Okay, and stack is famous for reversing a string or some data. तो क्या होगा अगर आप एक करके स्टैक में डाटा पुट करोगे से ABC is a string. If you put the characters say A to the stack, then B to the stack, then C to the stack, and then you will one by one pop from the stack. So you will get the output as CAB. That's the reverse string. Okay. What else? Yes. So the principle used in stack is last in, first out. You can think of the example that is the piling of the books. You can pile each one by one the books, and the last book that you keep on the top is the book that you can get very fast. That is the first book you can get easily. Okay. Coming on to queue. So what we do is that we again have push, pop, peek over here as well, and the push operation appears on the rear end, and the pop operation appears at the front end. Okay, and the peek operation also appears at the front end. So we have two pointers over here, front and rear, in case of implementation using arrays, and we have head and tail in case of implementation using linked list. Okay, single linked list. Then what is could be considered over here? Yes, the principle used over here is first in, first out. Person who comes first is the one who gets the chance first. Okay. Coming to priority queue. So over here we have add operation, we have poll operation. Okay, we have peak operation. Okay, and remember by default it works on ascending priorities. Okay, next is PQ, that is doubly ended queue. So on the front side we can have remove and add both at the time, and on the rear end also rear side we can have add and remove एट द सेम टाइम। ठीक है, एक साथ कर सकते हैं, दोनों एंड से हम निकाल भी सकते हैं, डाल भी सकते हैं elements को. We can insert also, we can remove also, we can add also, delete also. Okay, so these were little basics. I hope it works for you, and do have a check of the articles. आप articles को read कर सकते हैं. Okay, based on linked list, tag, cues for the basics. If you are short on the basics, I have tried my best to tell you minimum basics, because from MCQ point of view, they nobody can ask in very deep, okay? Because it's choice based. So, and if there are question that is not covered at all by me, so you can give a रीडिंग टू इट, एंड एक बार सोच के देखना, सिंपली सॉल्व हो जाएगा. बस बेसिक पता होना चाहिए कि स्टैक से ऐसा होता है, क्यू से ऐसा होता है. ठीक है, इस प्रोग्राम में ऐसा होता है, सेलिब्रिटी में ऐसा होता है, टावर ऑफ में ऐसा होता है. तो एक बार सोचना वहाँ पे. ठीक है, गिव अ थॉट, and I'm sure you will be able to answer it. It's not at all tough. Okay, so that's all for today. Thank you.